Okay, then let's start. Hello and welcome to the talk Testing AWS Lambda Functions. My name is Modood Alvi. I'm an AWS Solutions Architect. And today I'm sharing my experience with testing AWS Lambda functions in Java. So what is on the agenda for today? The talk is split into 3 parts. We have first a little bit of theory about test strategy and different test types. Then we will have a look into the design of a Lambda function and how to make it testable. And then we have a look at the tools available to make our testing easy and convenient. So then let's start. Now, I've been in love with Lambda since the very first beginning. So I love the idea to run code without provisioning any servers or any infrastructure. So you just upload your code and Lambda takes care of running and scaling your code. And you can basically run any type of application in Lambda. And since it's support for custom runtimes, the possibilities you have are really countless. We have just heard the talk about the custom runtime and what is available there. So it's really exciting what is happening in this space. And I've seen projects running Spring Boot apps and Next.js apps in Lambda, or training R-based machine learning models in Lambda. And we also see new developments around GraalVM and the frameworks which are coming from there and gaining more and more traction. So Lambda is already there and it's getting more and more mainstream. And that's why it's good to have a look at how to test Lambda functions properly. Just to look shortly also on the use cases we see. So that's one of the more typical use case, I would say, where you have your Lambda function basically as a microservice behind an API gateway. So on one side, you have your single page application with the static assets being placed in S3 and then provisioned via CloudFront to your users. And then on the other side, making calls to the API gateway where you have most probably a RESTful API and then exposing your different resources and a Lambda function sitting behind, reacting to the HTTP events and most probably storing, retrieving, querying your resources, in this case, using a DynamoDB. So that's a very common use case. We see a very common architecture with regards to single page applications, web applications, serverless web applications. And actually, there is also an immersion day where you can build such a web app in several hours and have it run in your account. And I can highly recommend going through that. It's a very nice experience. So, and then we have on the other side, more than 60 dedicated event types that can trigger your Lambda functions, with even more ways to basically integrate with different services, because you can have one event triggered by different occasions and different services. So what we can conclude here is, yes, Lambda can be used for almost any type of workloads. Of course, there are exceptions, and there will be always. But then it is also used to integrate between different AWS services. It is, so to speak, the integration backbone of AWS. And it basically glues together the different services and makes integration so easy and convenient the way we like it. So having put a little bit thought about the use cases, let's have a look at the strategy with regards to testing. Now, here a disclaimer from my side. Testing is really a very wide area and also sometimes complex, given the nature of your application, of course. And with this regard, there is no right or wrong in that. There is always, it depends, right? So what I would like to do is now in the following slides to share a little bit on my experience, but as usual, it's always about you to judge what makes sense, what is relevant, and what can be applied to your solution and use case. All right. Now, because we said Lambda is often used to integrate different services, right? We have this event-based architecture where Lambda gets triggered by different types of events and then usually process these events and then either produces a subsequent event which can be consumed by other services or trigger some other action. The emphasis in the testing should also be on the integration part, because it is about integrating different services. Integration should be also the main part with regards to testing. So that's why we typically move away from the traditional test pyramid we know with the unit integration and end-to-end test and move over more to the honeycomb-based approach, which is actually more common in a Microsoft-based, microservice-based and distributed system. Now, there is, of course, no replacement in running end-to-end tests in the cloud. And the reason why is AWS is your runtime environment. That's the big difference between, let's say, more traditional ways of developing, where you have, let's say, a runtime which is pretty similar to what you have on your local PC. But in this case, AWS Lambda runtime is in AWS, and that means there is always the point of deploying your services to AWS and make them run there, right? So that's why we have also the emphasis on end-to-end tests, but mainly the integration part. Now let's have a closer look on the different test types. Let's start here with the unit tests. Here we can basically have two distinctions between the unit tests. One is the solitary tests you see on the right side, where you basically test your unit under test and want to have it isolatedly tested. So there in your test, you only have your class under test or unit under test, and that's the only implementation you will find in the test, and everything else is mocked away. And then we have on the other side the sociable tests, which are more, let's say, broader in nature, as they also allow to have to cross boundaries here and also encompass collaboration. So there are pros and cons having solitary tests and sociable tests. I don't want to go too much into that, but just to have a rough distinction between the unit test types, or let's say also philosophies in testing your units, and what we can use to think about how we would do that in our Lambda environment. All right. So how would we do the unit testing with Lambda? So in the case where our Lambda is doing a lot of domain or business logic, right? And it's heavy on that, it makes sense to isolate your domain logic, probably in a separate module, component, package, whatever you find appropriate, and then testing this domain logic isolated with solitary tests and having the different integration to other services mocked away so you can concentrate on the domain logic. It sometimes also happens, or it's also often the case that your domain logic is already in a component that you're using, right? So you basically have a dependency to a component where your domain logic resides, and it is already properly unit tested, either by another team or you have it done in a separate project. So either way, either it is coming from a component where it is already tested, or you have it in your Lambda function code, but you extract it away in a separate module, class, package, and test it there. And then if your Lambda function is more on the side of integration and transformation, so let's say your function gets invoked by an event, you do some slight transformation of that event, and then either store it or produce another event, then the focus should be more using sociable test, where your Lambda handler is basically the unit and the entry point, and you test it together with the downstream services. That kind of test can be actually also seen as a integration test. So because you are using also the downstream services your Lambda is using, and here we are crossing boundaries and having two different systems talk to each other. So we are actually in the space of integration testing. That's why. Let's have a look at the different integration test types. So some general remarks here to pause a little bit before we go into that. So in your Lambda function should ideally not integrate more than two services. So it gets triggered, right, by an event, and then it basically consumes another service or stores that event, but it shouldn't do much more than that. So maybe max two services, right? But if you are trying to call different Lambda services, Lambda functions within your Lambda function, or doing more type of orchestration, it's best practice to split your Lambda function in different functions, every function taking care of one dedicated task and one single responsibility, so to speak, and then use either, let's say, stub functions to orchestrate these different Lambda functions, or you can also do it, of course, event-driven, like in a choreography, every event triggers another Lambda functions, which then triggers another one. Or you orchestrate it more in a controlled manner, like in a workflow or in a step functions flow. So some general remarks on that. Yeah. Now let's look at the different integration test types. We have on the left side the, let's say, local integration test, where you basically run your Lambda handler code locally on your machine, right? And try to emulate or mock the different services it consumes. There are different emulators out there. For example, a more prominent one is local stack, but there are also others, or there are specific ways to mock your service calls very transparently. So that's this space we are talking here. Then the hybrid approach would be you have your test run locally. It calls the Lambda handler, but the Lambda function itself calls the AWS services which you have set up before. So you have set up your stack already. They are there, and your Lambda function uses them, and you test in this hybrid fashion. And then we have the full, let's say, cloud approach or type, where you actually deploy your Lambda function and then make your test trigger the Lambda function by either calling the Lambda handler directly, or, which is even better, calling the service which triggers your Lambda function. So, for example, using the API gateway to trigger the HTTP event, or putting your event in a SQS, for example, which then triggers the Lambda function. And every of these different integration types, test types, has pros and cons. And as said before, there is no right or wrong. There are pros and cons. There are better ways and to go in this approach or the other way. Now, for the local testing, what we see is you are very fast, right? So if you are, for example, using mocks or these emulator services, you can run your unit test and integration test pretty fast. That's very neat, and that's what we actually want as a developer. Also, we want to work on tests and not rely on, let's say, the internet connection. However, one sentence about that, I would say in the rare case, we have to work in an airport or a train where we don't have any internet connection. So it is very neat, for sure, to work on your tests and execute and run them without any internet connection. However, I would say practically, it's very rare. Then we have cost-wise, it's very good running locally, of course, because we don't have to pay for any consumption. And then also, if you encounter an issue in your implementation, you can diagnose it very well, for example, by debugging your code. And that's very much doable locally, and that's something we also prefer. However, on the confidence side, you lose here a little bit. One reason is some services can't be emulated, right? Secondly, the emulators will always lag behind, and there will be no total feature parity. So on one side, then also the configuration is very hard to test, also service quotas, IAM policies, and so on. So you can't be very sure that this actually would run also in production when your integration test succeeds. So that's why we have a little bit less confidence here. Let's go over to the hybrid. There, we still have a good speed, I would say, because in the ideal case, you do the deployment of your stack once, right? So the infrastructure is there, the services you want to consume are there, right? And there are usually not very much changes in the stack itself. It's more like you have it deployed once, and then you iterate on your Lambda function code and test on that, right? So you have still, I would say, quite fast feedback cycle when you run your code locally, but against real services. You gain much more confidence, right? Because you are not mocking away, you don't hit these emulators limits and so on, and you can still do a good diagnosis in a sense that when your Lambda code is not working correctly, you can still debug it, right? We have, of course, costs in setting up the infrastructure and the services and the consumption of that. And that's why we are a little bit more expensive than the local approach. And then the full cloud, there I would say you have the most confidence, right? Because you can really test also the different quotas, the authorizations, and so on. However, doing a deployment every time you do a change is, of course, slow. And then, and then with regards to the diagnosis, that's a typical issue you have in any distributed system. When something goes wrong, you have to have a good observability to actually then root cause your issue, right? And then with regards to costs, yeah, dependent on the way you set up your infrastructure, you might have also more cost in deploying every time a new version of your code. Now, looking at the different integration test types here, I would say from my experience, the hybrid approach is very much what you want to go with in a lot of cases, because it gives you kind of the best of all. And you are pretty confident that your code then can also run in a full cloud environment. And in the best case, you write your tests in a way that you can run it locally, but you reuse the same test in your CI/CD and have it even be used in end-to-end tests. Okay, some words about the test setup. So one pattern we see for organizing your accounts is you have these different environments, right? So you want to have a development environment or account where you want to have, let's say, give the developers more possibilities to think around, play around with services, have a little bit a more open, let's say, IAM policies in place, and where your developers can actually experiment a lot. On the other hand, on the production accounts, you have your sensitive data, of course, and you want to keep it as much protected as possible with the least privilege principle, of course, applied. And then there are some organizations actually who go that far that they restrict actually console access to the production environment, and the creation of resources or the change of the infrastructure is then basically only over CI/CD pipelines possible. Now, looking then into the test environment or development environment itself, there are several ways to set this up. One example here is using one single AWS account in which you then deploy different stacks for each developer. So here in this case, Alice can make changes to any part of her stack, play around with that without disrupting Bob or Jane. And so in this account setup, you have to, of course, set up your stack in a way that it basically has a unique name. So every resource has a unique name, and you want to avoid naming conflicts and so on. So there, what I've seen or also done by myself is having kind of a prefix for your stack, and then also the naming of the resources, for example, or you let your infrastructure as code framework create your unique names, right? So you don't hard code any name here and reference that properly in your setup. All right, that's so far about the strategy, right? So we want to go more in the hybrid space. We want to have a setup where we can create our stack, and that's where you start. So you create your stack, you create a new feature, you deploy a new feature branch, you deploy, and then you think around and write your tests. And when you're confident with what you have achieved, then you go into the CI/CD pipelines. All right, now let's have a short recap, let's say, about some best practices when it comes to writing Lambda function as such. So what I will present here is actually nothing new, I would say. You most probably will already do a lot of that in your code base already. And the frameworks which are available actually support us very well. And the concepts are established. It's just a recap that it also applies to writing Lambda functions. So here we can see, let's say, typical example of a Lambda handler. In this case, we get a API gateway event and return a response event. And what you can see here is it's kind of a monolithic Lambda. So we try to squeeze in everything and react to all the different HTTP methods. And that's something here again, you should consider in separating your functions according to the verbs and making them much leaner. In this case, we can also see that there is a tight coupling to the way you want to store your resource or retrieve your resource. In this case, we immediately create a DynamoDB client, and that's something we also want to avoid. Then what you also see is you basically take the body of your request, right, and map it directly to the item which is then used to store in the DynamoDB table. But actually what you want is you want to first transform whatever you get from your event and put it into your domain event, right? Because every event we receive in Lambda, it has a meaning. It is in your context, it is a specific event type, right? And you want to first transform it into this event and then process it. We also have here the hard-coded table name and the magic number for the return status code and so on. So that's nothing new. So the general advice here is go with the hexagon architecture. So that's one way to deal with that. And I'm pretty sure we probably already do that in the one or the other way. It's basically aiming to create loosely coupled application components that can be then easily also exchanged and help very much in the setup of tests and test automation. And so the core idea here is to isolate your domain logic and make it more or less independent of, let's say, the infrastructure and the surrounding service implementation. So you could get your event via an API gateway as an HTTP event, but it could be also delivered through a GraphQL API, for example, right? So your domain logic should not be dependent whether the event you're receiving is coming from a REST endpoint or a GraphQL endpoint. And if you do it right, your core domain logic has no dependencies to, let's say, the way, for example, your events are conveyed to you. And I've seen also projects where even the annotation, the JSON annotations are left out from the domain model, because that at the end implies that you want to have it serialized as a JSON, but it doesn't have to be, right? That's basically also, let's say a very general concept. And that's something we also want to apply in our Lambda functions. Here, a very easy, simple, rough example where we have our Lambda handler, right? And we use a profile repository interface to then further process the event we receive. And in the default case, it's a DynamoDB-based repository where we access a DynamoDB table, but it doesn't have to be, right? So in the test setup, you can then, of course, inject your either test repositories or then have different configurations for different environments. And in the handler test itself, we first extract the domain object or the entity or the domain event, and depends, and then process it, right? And the processing is very simple in this case. We just create a profile via the repository interface, but it could be more, right? So you can use then your aggregates or your service objects and so on, and do your processing there, and then you return a result, which then gets transformed back by the handler code into the in this case the API gateway response event, but could be any other event. Okay, now that we have talked about the, let's say, design principles to make your Lambda functions testable, let's have a look at the tools available to make our life easy with regards to testing or having a fast development feedback loop. Here first, I want to mention SAM. SAM is the AWS serverless application model. It's an open source framework, and it helps you building serverless applications. And what it does is it basically provides you a shorthand syntax to express functions, APIs, databases, event source mappings, and so on. It's kind of a leaner way to write your CloudFormation templates, right? And that's actually what it does. It takes the SAM template and it translates it to CloudFormation templates, which then gets executed, deployed, and your stack is built on top of that. But more than that, it also provides you a CLI, a command line interface, and that's where you can also run your applications locally. One command we have here is the SAM local invoke, which basically invokes your Lambda function locally. SAM uses Docker environment and then deploys your function and then executes it. And this environment should be pretty similar to what we have in AWS. However, it is at the end an emulator. Then we have a second one, which is SAM local start API, which is also very neat. So you define your API and the endpoints and the resources in your SAM template, and SAM local start API takes that and creates a local API gateway, also with the Docker in a Docker environment, and exposes your API on your local host, which can then be accessed by either your UI, or you can test it with any REST or HTTP client. Then we have the AWS DynamoDB emulator, which can be also downloaded from AWS website. And this allows you basically run a local DynamoDB and use it in your tests. So one way is to run it like in this as a separate process, right? And then reference your unit test to that instance by overriding the endpoint. So when you create your DynamoDB client, you can override the endpoints and point it to localhost and then use it in your tests. There is also actually a way to start that in your JUnit test itself, right? So you don't have to do that in this way. You can use a server class and start it with the different parameters, and then also tear it down after your tests. Here again, we are using an emulator, right? So be cautious about that. And neat part of this is, as it is coming from AWS, there is, of course, this, let's say, yeah, the target to have it very close and really provide you a lot of confidence with regards to your test, and it is maintained by AWS. So I have seen projects where you start your DynamoDB, point your Lambda functions to it, and then have either SAM used to expose your API, or have a simple wrapper where you start a local test server, right? And every HTTP request which comes to this test server is then transformed to the API gateway request event and provided to the Lambda handler. And you can basically run your whole single page application locally, including the API gateway part and the DynamoDB part, which makes it sometimes very neat to develop your applications, your single page applications, web applications here. Then we have the AWS Java Event Serialization Library. That's actually very neat when it comes to using different events, right? I talked about the 60 different event types. And what you can do is you can put your different events in your test resource folder, right? Load it from there and then invoke your Lambda handler with that. The way AWS Java SDK serializes and deserializes the events is sometimes not straightforward. So you can't always use, let's say, the normal object mapper from Jackson, for example. And that's why we provided this library to make your life easy in serializing, deserializing the different event types and use them in your tests. And built upon that is actually also a library, which is the Lambda test library. It uses the serialization library and provides you some convenience on how to set up your tests. So in this example, you just provide via annotation the event you want to load from your test resources folder and the event type, right? And it provides you this event, and you can directly pass it to your event handler and execute it. And yeah, also have a look at that. I think that's also something very convenient when it comes to writing your unit tests. All right, so that's on my side for the different test strategies and design and tools. And I think now we have some time for Q&A.